Alright, hola, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to talk about moles in chemistry and just in life in general, I guess. Okay, let's get into it. What is a mole? Well, a mole is just a measurement of something, and it's based on this number called Avogadro's number, right? Which kind of studied and found this number that was 6.02 times 10 to the 23rd. If you don't know what that is, that's 602, and then there's 21 zeros. So if you want that written out, you'd be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. That is Avogadro's number. That is a mole. So if you're talking about a mole and you say that's just too much to look at, you're like, what does that even mean? There is no context here. Well, if you had $1,000,000, like, would you be called a millionaire? I don't know. But you'd have 6.02 times 10 to the 23rd dollars. You could probably you just could buy like the world, right? You could probably buy a planet if you wanted to. You could buy everything, right? And still have a ton of money left. You could probably get your way all the way out of the solar system with it. Maybe. It's a lot of money, right? If you had this many squirrels on Earth, the Earth would overheat and we'd all go crazy. Like everything would die if we had this many squirrels. So it's just a huge number is what you need to know, right? A mole is a measurement and it's a huge amount of something, right? So if you say, okay, how many molecules of something are per mole? You say, okay, there's 6.02 times 10 to the 23rd molecules per mole. Now that makes it easier for chemistry purposes. So if you said, okay, get me a mole of water, right? You can't count out 6.02 times 10 to the 23rd molecules of water, right? Even if everyone on Earth started counting, right? Like for the rest of their life, you added it up, they still wouldn't get to a mole by the time they're all dead, right? It is so incredibly large. But what is super cool is that a mole of let's say calcium chloride, right, is just like add up the AMUs, right, and then turn that into grams. So you just say AMU goes to grams, and that just is like 1 mole. So if you look at your periodic table, hydrogen has like an atomic mass units 1.008 per molecule, right? But if you were to have a mole of hydrogen, you'd have 1.008 grams of hydrogen. And that's saying if you just had hydrogen by itself, like maybe a hydrogen ion, because if you just had hydrogen by itself, it would be H2. But just say hydrogen ion, you'd have 1.008 grams of hydrogen, and that would be 1 mole. So if we said we have a mole of calcium chloride, first what you're going to do is add, you're going to say, okay, how many grams is 1 mole CaCO? Well, Ca. So Ca, you look at your periodic table, it tells you it's 4.078. Just put that in grams and that's 1 mole. 40.078, that looks like a 9. Did not mean that to happen, but okay. And then Cl, if we look at our periodic table, Cl, we are given it's 35.45. Now, you just add them. So this will be 40.078 plus 2 times 35.45 would equal, 1 second, 40.078 plus 2 times 35.45 equals 110.978 grams. So a mole of calcium chloride is 110.978 grams. Now, what if you were told something like this? You were told you had a certain amount of a substance. Now say how many moles of it you have, right? And this is important. In a ratio, like CaCl2, CaCl2, for every 1 mole of calcium we have, it will fully react with 2 moles of chloride. So if you had like Ca plus Cl2 yields this, something like that, maybe. Like this is just net ionic equation. If we had this, reacts to make this, right? For every 1 calcium here, like for every 1 mole of calcium we have, we can make 1 mole of calcium chloride. So that's what we're trying to get at. It's just molar ratios. So first, if you are given that you had 32.0 grams of CH4, how many moles do you have? Well, first find 1 mole CH4 would be equal to like 1 mole of carbon plus 4 moles of hydrogen. So a mole of carbon would be 2.011, and then you'd add that to 4 times 1.008, which is like 1 mole of hydrogen, and that would give you 16.043 grams. So we say, okay, we have 32.0 grams CH4. Now to get this into moles, we say times 1 mole, there is 16.043 grams, right? So if we did 32 divided by 16.043, we'd get 1.9946, which is kind of 2, but you get like 1.99464, and you can just let this calculator run out. All right, so that's what you're given. And then if you're giving something like you get this many moles, now find how many grams it is, you do the same exact thing. You say, okay, if we have, let's do 17.2 moles of C6H12O6. First, 1 mole C6H12O6 is, make sure there's no calculator error here. Oh, that almost just went on my white carpet. That would have been bad. So 6 moles of carbon would be 72.066. And then you add that to 12 moles of hydrogen, would give you 84.162. And then you add that to 6 moles of oxygen, and that would give you 180.156 grams. So we have 17.2 moles, right? And we need to multiply that. We need to get rid of the mole, so we have to put mole on the bottom, right? And there's 180.156 grams per mole. So moles cancel, right? And we just do 17.2 times 180.156, and that would give us, oh, that's 3098.6832 grams. So if you were told to measure something out, if you were told to measure out 17.2 moles of like glucose, you would have to measure out 3098.68 grams of glucose. Okay, so that's what a mole is. Again, a mole is just Avogadro's number, 6.02 times 10 to the 23rd. It's a measurement. But if you're told you have a mole of something, you have an incredibly large amount. And all that matters here is that on the periodic table, we are given like these AMUs, right? So like lithium has an AMU like mass of 6.94 AMU. But if you have a mole of lithium, you just turn that AMU into grams. So take the number right off your periodic table, put a grams after it, and that's 1 mole of it. If you have a compound like C6H12O6, you say, okay, 6 moles of carbon plus 12 moles of hydrogen plus 6 moles of oxygen would give me 1 mole of C6H12O6. Then that's kind of it. And then if you're told, well, like you get this little equation, you get like NaCl, that does not look like a C, plus like H yields, what would this be? HCl, hydrochloric acid or something, and sodium, right? You'd say, okay, so if you're given like 32 grams, this is stoichiometry, which there's going to be a video on it. If you're given like 32 grams of sodium, right, how many moles of hydrochloric acid can you make? Well, you're like, okay, well, what's the molar weight of 1 mole of sodium, right? Then find out how many moles of sodium we have, then find the ratio between sodium and hydrochloric acid, and then find out how many moles of hydrochloric acid we could find by finding the molar mass of hydrochloric acid. So this is stoichiometry afterwards, but I hope this video on moles was helpful. Please, I will answer any comments down below, and thank you so very much for watching.